It's wonderful to see you all. Honorable Consul General Manish, thank you so much for coming. Ladies and gentlemen, I also welcome all the participants that are online. Thank you so much for joining us. Today, we are going to focus on robotic manufacturing as it applies to 3D printed homes. Now, let's put this in a little bit of a context, and let's see how our burgeoning housing crisis in Canada, in India, and of course, indeed around the world has been. So if you listen to a recent Senate report that just came out actually a month ago, it estimates that 40,000 units are urgently needed in our Indigenous communities. And by 2031, I mean, how bad this problem is getting, the backlog will rise to about 130,000 units just in our Indigenous community, which really means that we have a very large problem at our hand in this country. Now, considering the existing homes in the north, nearly 45,000 units need major repair. So repair and rehabilitation of our housing in the north is a major, major concern. And get this, half of them are infested with mold right now, half of them. What that means is that we have created this very unhealthy conditions for our Indigenous people to live, which is really creating severe respiratory illnesses, a number of other health-related concerns that our First Nations are facing in these northern communities. We really have something to do. We must do something, and I think it's a humanitarian crisis that we really have to address as a country. Now, how did we arrive at such dire straits? And I mean, if you're looking for solutions, you have to also look at the problem. Leaving aside the financial issues, which is of course very large, building in the north is difficult, clearly. Building season is short, and as what COVID-19 has taught us, the supply management has become a very large issue, particularly for building in the north. Building season is short, supply management issues, as I said, are enormous, and climate change is making transportation difficult with disappearing permafrost. Those roads that existed before this climate change started to take place are now disappearing because permafrost is disappearing. You cannot actually ride your vehicles on them anymore. So that's another very large issue that we are facing in terms of this climate change, that our access routes are now somehow shrunk. Harsh weather, of course, not to mention that, and lack of existing transportation structure, as I said, we believe that 3D printing may be a very viable option for these homes up in the north for a number of reasons that we will discuss today. Now, in India, lack of housing is one of the pressing issues as well. Now, India, urban housing shortage rose to 29 million units. So the urban housing shortage in India right now is about 29 million units, which means India needs to really ramp up its housing construction as we move forward. And a recent Government of India report opined that India needs rapid methods of construction like 3D printing, robotic assembly, and of course, India wants to be carbon neutral by 2070, which means we really require carbon neutral building materials. Canada, that wants to be carbon neutral by 2050, clearly, given the carbon footprint of our infrastructure or the built environment sector, which is almost 39% of our global greenhouse gas emissions, just from our built environment, the only way we can become carbon neutral by reducing the emissions from our built environment, which means you require carbon neutral construction, carbon neutral materials, and carbon neutral processes. So today, what we hope to discuss is basically not just the construction part of these 3D printed homes, but also how do we make them carbon neutral? How do we make them smart? How do we put sensors in them? And how do we ensure that they're resilient to all of the vagaries of climate that already exist and because of climate change are going to get worse as we speak? Our floods of November in British Columbia taught us a lot. We are really not ready for these disasters. And I think we really need to come together to build these homes which are resilient, carbon neutral, and durable. So welcome to the workshop on this robotic manufacturing technologies for building carbon neutral homes. Hopefully today's 6 presentations will elucidate the progress of manufacturing homes through 3D printing and help us find the pathway to alleviate our housing concerns. Welcome again, and thank you for being here.
Very good morning to all of you. A very warm welcome to everybody around the table. It's so delightful to meet everyone in person after a long hiatus of about 2 years. I've been here a few times, but this is a very special moment for us. Thank you, Dr. Nemi Bentia, for agreeing to host this workshop along with the Consulate on the theme of robotics manufacturing. I welcome everyone, those who have joined us virtually from around the globe, participants from India, Canada, Germany, and China. I also welcome the faculty members and students and industry leaders who are here today. And of course, a warm welcome to my countrymen who has joined from Guwahati, Dr. Biranchi Panda, who is one of the speakers here. As during his initial opening remarks, already mentioned about the scheme of Government of India, Make in India initiative, which was launched in 2015. And it is a national program of Government of India designed to facilitate investment, foster innovation, enhance skill development, protect intellectual property, and build best in the class of manufacturing infrastructure in the country. It was initiated in 2015 during the first term of the current government, Prime Minister Narendra Singh Modi ji, and has gained traction over the years, and especially during the post-pandemic, when many countries are looking to manufacture in India and create alternative supply chains, because we have all seen how global supply chain got disrupted around the globe under the what geostrategic people are saying China +1 strategy. The Make in India strategy got bolstered and the new initiative is called Atmanirbhar Bharat, or the Resilient India or Self-Reliant India, which seeks to incentivize manufacturing under 13 broad sectors. There is a special incentives called production-linked incentives, schemes in 13 sectors like aviation, electronics, automobiles, chemicals, renewable, pharma, which was opened up by the Government of India for greenfield investment in manufacturing and has drawn a lot of interest from global community. As India becomes the center of attraction for manufacturing, we see great potential in India-Canada partnership in technology, as the two countries share complementary expertise and business and interest in these areas. To tell you frankly, I think we had a ministerial meeting a few weeks ago when the Trade Minister of Canada visited India. The India-Canada Economic Corridor is about $100 billion worth, and a lot of your big pension fund houses are investing in infrastructure space in India. And we are going to start negotiation on comprehensive economic partnership agreement, which was launched about a decade ago. We'll start working on that. But before the conclusion of the ambitious comprehensive economic partnership agreement, we would be doing a smaller undertaking, which we hope to finish within a year, which will be kind of concluding agreement on a low-hanging fruits. So I think our relationship on economic agenda is going very much on track, and a lot of things are happening in economic space. And institutions like IC Impact is one of the major platforms which both countries, India and Canada, are working through joint research in cutting-edge technologies. And today's workshop is a step in that direction. I believe that this focused workshop on robotic manufacturing technologies for building carbon neutral homes will forge collaboration between the two sides and strengthen already vibrant partnership between our research bodies in both the countries. Just to give a brief overview of the robotics market in India, I think it gained momentum post-industrial expansion, digital revolution, and adoption of automation at a large scale. In terms of annual installation, the industrial robotics market in India stood at about 5,000 units in 2019, and it has reached about 11,760 units by 2025. Which is a growth of about 14.5%. But as I was talking to Dr. Bentia, most of our robotics related technology is being used in automotive sectors and health sectors. And I believe this, you have already worked on some technologies like 3D printing under the IC impact, which would find use in India. You have also developed some sensors for predicting damages to the building, or which we have also reported and have found which can be useful to our own setup in India. So I hope that this workshop today comes out with some serious recommendation and way forward by which we can collaborate and between the two countries, India and Canada. And I once again thank Dr. Nemi Banthia and his team here and all the participants here who have found time to join with us for this informative and useful workshop. Thank you once again.
Thank you, Manishji, for highlighting how technology can be harnessed for increasing the business and trade opportunities between the two countries. We are thankful for all your esteemed support. So moving on to the talks for today, we have our first speaker, Dr. Biranchi Panda, who is joining us from India. It's late night there, and we sincerely thank you, Dr. Panda, for joining for a live talk. Dr. Panda is an assistant professor at the Indian Institute of Technology, Guwahati, and is a renowned expert in the area of additively manufactured sustainable multifunctional composites and digital construction. So I will hand it over to Dr. Panda.
Good morning to all of you. Thank you for the introduction and this invitation to discuss about what is the way we can relook into the way we are manufacturing this kind of homes. And already Professor Bantia and Manishji has highlighted the need to relook into the way we are creating homes. It's a really a big fact that in India, there are really lacking of houses. So being a professor of mechanical engineering department, I look into this problem from a different point of view. The point that already you have highlighted that we need to bring some innovation in the construction so that we can create these homes at a much faster pace. So in this regard, what I believe, being a mechanical engineer, that we should change our attitude from a project point of view towards a product point of view. What I mean by that, so we feel that when we are creating a home these days, it is very obvious that we have to first buy the land, and then we have to hire some contractor who can make the house for us. We have to get the raw materials. So instead of looking these things into this kind of perspective, which is a more like project based, you need to get the land, you need to get the contractor, materials, you need to hire an architect, designer who will going to make your house. So instead of having this kind of approach, I feel that with the 3D printing or additive manufacturing, we can directly jump into an approach of a product based item, so that tomorrow in the future, we are going to entirely print the buildings for you, and you are going to select the product like your home. Sometimes we go to shopping malls to buy clothes, cars, all these things directly as a product for us. So I believe that in future, our approach should be something not in the project kind of based. It should be from a product point of view. It means the entire house can be made into in a factory by an automation or automated machines, which can be a robot, which can be a gantry based machine. So today I'm here to share some of our activity, that research activity that are being done at IIT Guwahati. I completed my PhD from Nanyang Technological University, Singapore. So just 1 year back, I joined IIT Guwahati as an assistant professor. So we do research on digital construction. So you can see a robot is printing some structures. Definitely we have much more higher productivity than compared to the traditional way of creating construction structures. And also in recent newspaper articles, I have seen that the World Economic Forum has also pointed out the need to automate our construction industry through various technology like IoT, 3D printing. So different new technology can be combined together to automate our building process, so that tomorrow the process can be more faster and we can get a more quality and robust component out of that. Having said that, there are different strategy which is coming under the umbrella of digital constructions. 3D concrete printing is one of the technology that is also getting a lot of attention from both academia and industry. In fact, when I joined India, I got a lot of response from different companies like JSW, JK Cement, who are very keen to invest on different concrete printing project. For me, when I look into the concrete printing project, I feel that there is huge need to understand the technological benefits. For me, I see the benefit in terms of design freedom. You can see an example of this kind of complicated geometry that has been printed by a French company, X3. So you can imagine the degree of complexity here that has been done with the help of 3D printer without the need of any mold. Similarly, the other benefit, what I also feel, the sustainability point. What I mean by sustainability, definitely we can bring more sustainable materials to create such kind of structures. But for me, I feel that if you see this breeze, the entire the cross section area has been topological optimized, and this work has been done at Netherlands. So we feel that through 3D printing, we can also redesign our structures to minimize the concrete waste, and thereby we can minimize the problem with the production of the cement. So during my PhD, I was using two different type of machine. One you can see on my screen. It's a more like a gantry based system. So on the left hand side, you can see a controller. We have a pump here. So we simply pump the materials to deposit it layer by layer. But it is small scale machines. Then we had a large scale robotic printer, which we used to print a prefab bathroom unit. So I'm going to show you some of the videos later. So what I feel that when we are talking about such a technology, it is very important for us being a scientist to know what are the key factors that are important from a researcher's point of view to explore this window. So definitely materials are important. So when we are dealing with materials of concrete printing, it have to be properly designed. We can't print a very fluid concrete because it's not going to take the shape. And even we are going to make it more steep, we can see some discontinuity layer during printing. So we need to properly balance that material rheology. So more we have to bring texturotropy kind of material which can be pumpable and printable. And in this regard, when you are going for large scale printing, such as for you want to print a entire home, then of course we need to take into account the structural build of the material. If that is a poor, then definitely after printing few layers, you are going to end up with such kind of structures which is going to be collapsed very soon. In other way, if you are going to have a material having very high structural built-up rate, then you are going to end up with poor bond interlayer bond strength. So it means that if we want to promote such kind of technology, we must have a proper material science background so that we can develop a proper material for such technology. Having said that, when we have cement, the ordinary Portland cement, which is most commonly used in everywhere these days, in India especially, so you don't see any problem because we get some inherent texturotropy because of the cement particles. But if we want to promote some kind of sustainable materials like fly ash, industry wastage like slag, so recently we are working with 2 or 3 different companies who are providing us this kind of industrial byproducts, and we are trying to use them in the material formulation. So we see many challenges. For example, if you take the fly ash, due to spherical shape, we are not getting proper buildability, and therefore we have used some kind of nano materials. So you can see that you are going to use lot of fly ash in the material formulation, and if it is not properly designed, then you will see poor buildability after printing a few layers. So in this regard, what we did, we used the nano clay powders, and we see that by the flocculation mechanism we have improved the buildability. And this buildability is all from material side. Then this is the story for the material, but also we have done some research on the machine side. So during printing, we have added some kind of laser sensors to track the layer height deformation, and this all the informations we are going to store in a cloud at point database. And then with the help of an AI network, we have optimized the parameter settings so that during printing, if the material sense that the deformation, then automatically the parameters are going to be adjusted so that you are not going to see any collapse during printing. So from the material point of view, we have done some texturotropy characterizations. I think it can be discussed in a more material conferences. But having said that, it is very important to understand the material behavior during 3D printing. And we have done some characterization like a green strength test. And also with the help of advanced modeling, we try to understand the buildability of such kind of materials, so that when we are going to print a large scale structures, we can easily see how the layers are going to fail. So it is also important to understand the technological parameters of the machine, such as you are printing with a high speed robotic 3D printer, then you must know what are the limitations you have from the robot design point of view. So we have seen that when you are printing with a different speed, we have some different layer deformation. We are not getting the exact layer shape as we want. So we have to optimize the print speed. Apart from that, your printing nozzle diameter the shape also affect the robustness of the concrete that you are making. So when you are again recommending a 3D printing home, it is very important to understand the proper details like robotic parameters, the nozzle you are using, the materials you are having. So all these things together affect your final structure robustness. So having all this background knowledge, we started to work on some project like toilet printing. So I remember when I was in Singapore on the event of the World Toilet Day, we printed this toilet unit. And during the design phase, we found that it is also very important for an architect to understand the constraint of 3D printing so that he can better design a structure for such kind of applications. You can see a example on my screen that when we are printing this kind of structures, we had a curvature, and we try to optimize the parametric settings so that we should not get such kind of surface crack during printing. So again, it's an example of like how you try with the material combinations, how you optimize the print parameters so that you can end up with a proper robust printing. So with this background, so we did our first step, and also we have done some strength testing to make sure the structure, whatever we are printing, it's robust. So we have done the compression test, we have done the bond test to find the optimum time gap between the layers. So, and once we have all the knowledge, then we started printing the toilet unit. And I remember that day that our Honorable Prime Minister Ji, he was there. So invited him to demonstrate the capability of this digital construction technology. He appreciated that this entire toilet unit was printed within 30 minutes. So, and then our next project was to print a prefab bathroom unit using the large scale robotic printer. So you can see it's almost like 3.3 meter tall bathroom unit. And with our sponsor Semcob, we plan to print the prefab unit completely with using the large scale robotic setup. So we have printed the structure only, and after that we went for several tests that was recommended by Singapore Building Counseling, and we passed almost most of the tests. And now we are in the stage to promote the technology to make some prefab items so that directly this prefab furnitures or this kind of structures can be directly installed during the entire house making process. So, and then we have some small robots. Sometimes we do some funny research like printing on a curb platform. And the main key idea was that printing this kind of curb panels can be used as a facade in the building applications. So recently when I joined IIT Guwahati, so we made our first 3D printer. So it's a small 3D printer, but still we developed our own materials to print some kind of lattice structures. We collaborated with 2 or 3 companies who are providing us industry best to make their to make the final material more sustainable. And also we are in a process to discuss with some companies, and we want to do the first ever on-site 3D printing of homes in India. And in this regard, we are discussing with many companies for funding. And recently my students, they have printed some kind of furnitures just to demonstrate the capability of the technology to create some kind of free-form designs. So we are also making some kind of advanced nozzle where we can mix accelerator as well as different colors. So an example you can see on the right hand side, that if you want to have a different colors for your building, that also feasible in the digital technology. We can add different colors and different patterns as you want in the 3D design. So yeah, with this I would like to thanks the entire team who was involved in the material development, printing all these things. So we are now looking into commercialize this kind of technology, and also we are interested to do a on-site 3D printing of home so that the technology can be viable. We are also in the process of investigating the cost analysis and the durability of the material, which has not been properly studied in the literature. And hopefully with this knowledge from experts and from our team and other researchers, definitely one day 3D printing can be an alternative options to create such kind of large scale structures. So with this, I would like to conclude my talk. Thank you for your attention. If you have any questions, I'll be happy to discuss. Thank you.
Thank you so much, Dr. Biranchi, for your presentation. We will have a panel discussion regarding the talks of all the speakers combinedly at the end of the talk. So thank you so much for your presentation. Moving on to our next speaker. Our next speaker is Dr. Mark Green. Dr. Green is Professor, Provost, and Vice Principal Academic at the Queen's University in Canada. His research interests lie in the structural performance in the fire of concrete structures, applications of fiber-reinforced polymers in structures, and the effects of cold regions on concrete structures. So all over to you, Dr. Mark.
Okay, great. So thank you for inviting me here today. And I see the title was appropriately picked for me with my last name in the start of the title. And I also want to acknowledge that I am here in Kingston and coming from traditional territory of both the Haudenosaunee and the Anishinaabe peoples. And also myself, I am a member of the Mohawks of the Bay of Quinte, and my Mohawk name is Raswaherha, and I sit with the Turtle Clan in Tyendinaga. And Raswaherha actually means he builds a bridge, and I did get that name as part of my connection to civil engineering. So just one second here. So I want to talk to start is some of the work that I was involved with that was led through Queen's in sustainable engineering and remote areas. And this was an insert create program that involved 4 different universities, Queen's, University of Manitoba, Ottawa, and the Royal Military College. And what we were looking at were some different technologies in 2 research themes, one in renewable energy, but also in sustainable buildings, and looking at building in the north and some of those challenges. One of the things in defining sustainable engineering as part of that program, we looked at out of the Brundtland report gives this definition about meeting the needs of the future without compromising or meeting the needs of the present without compromising those of the future. But also recognize that that thinking is something that is long shared by many Indigenous communities. And one of the teachings that's often found is thinking of a 7 generation. And so that in making decisions in that tradition of 7 generations teachings is to think not only what is good for this generation, but what will be good for 7 generations into the future. And that often also goes back into the past to be thinking about how what we're doing now is informed by what our ancestors for the past 7 generations have also provided to us. So some of the things that we did as part of this project or program was looking at training of graduate students and others, and focusing on incorporating Indigenous culture along with sustainability business skills, and having many different opportunities for learning. So we have completed the 6 years of this CREATE program with a substantial number of participants at various levels, graduate, doctoral, and masters. And so as you can see from this, well, about 60 different students who have been trained. And as part of that, almost a third of the students were Indigenous students. And we had a focus to bring undergraduate Indigenous students and provide summer internships with the program in research. So that was something. We also had 3 graduate students who were also Indigenous as part of that. So I mentioned earlier, and also Dr. Banthia talked about some of the housing conditions in First Nations. So some of these pictures and also the statistics look at the challenges that are in many of the communities, both and looking at sort of almost 1/5 of people are either in Indigenous communities live in houses that need major repairs or overcrowding situations such as you're seeing on the right. And certainly that has been identified as a crisis situation. So one of the projects or programs, and this was done at the University of Manitoba, was working with some Manitoba First Nations communities to develop housing evaluations in First Nations, and ultimately to develop good building practices for First Nations communities. And so the PhD student, Patrick Glue, who himself is Métis, did a lot of this work, and it also remember the importance that it started with community partnership, and they intentionally use partnership as opposed to consultation, because sometimes consultation can feel one-sided from Indigenous communities. And you can see a community gathering here to set some of the goals for the research. And as also when the research outcomes came out, that they were very intentional to make certain that those results were provided to the communities first, and looking at benefits to community. So I also want to talk about a couple of different technologies that have been explored as part of the SARA program. And one that's shown here, and this is some work that was done with a postdoctoral fellow, Salas Sarhat, and master student Emma Keeler on compressed earth blocks, and shows some of the manufacture here and homes that can be built out of this using local materials. So this is probably getting far from the robotic technologies, but it can be something that is used as a good technology on site, that can use on-site materials. And so one of the things we were looking at were evaluating freeze-thaw durability and testing both in compression and in flexure. And overall, we did find quite good performance in those environments. Another area is my colleague, Colin McDougall, who has been looking at a number of technologies of using straw bales. And you can see straw that's inside, and then you have plaster on the sides to evaluate what the structural performance. You can see the walls being tested here, and also buildings that have been produced with that. And further technologies in these cases for this Zero House project, looking at prefabricated systems that incorporate some of those similar technologies. Additionally, my colleague Amir Pham, together with one of his graduate students, Luke Kodar, was looking at innovative sandwich panels using fiber reinforced polymers. And these were with using natural fibers. And so evaluating flax against glass in this application, and doing testing and the performance as columns, basically, in this case, columns or walls. And they found that the structural effectiveness of 3 of the flax layers was comparable to 1 of that of glass. But it actually turns out that the 1 glass layer was also approximately equal to the thickness of the 3 flax layers. Additionally, they looked at the long-term strength retention, and at 100 years, they found that for glass, it was 80%, and a bit lower for the flax at only 60%, but still very promising for technology. And Amir Pham and his group have also extended these ideas of wall panels into ultra-high performance concrete, double-wide insulated panels. And I've been recently working on a project in collaboration to start to look at the fire performance of such structures. And that involves both material testing, numerical modeling, and some full-scale testing. So just to give a little overview here, we've been making ultra-high performance cylinders for compression testing, and some direct tensile testing specimens that we can insert into into our high temperature testing machine that's shown here, and to evaluate those structural parameters at high temperature so that we can estimate what might happen in a fire scenario. So then ultimately, after we do the material modeling, we are going to be looking at doing these tests in collaboration with the National Research Council in Ottawa and doing some full-scale wall furnace tests. So we're quite interested in the results that might come out of that. So in the theme of this workshop, we are also looking at Queens into 3D printed concrete houses. And that's championed by my two colleagues, Amir Pham, and the newest member of our structural team, Joshua Woods at Queens. And we're working with a company, Nidius 3D. And you can see we already had some explanation of all the benefits that can be achieved through these technologies. And these are some of the ideas of what we're looking at as various options for monitoring. And I think that in working with the company, we are looking for many different options that will encompass many of our faculty members in civil engineering at Queen's and structures. So I just wanted to end with a few concluding thoughts. Certainly housing is a critical issue for First Nations communities. We really need to be intentional in engagement and partnership with First Nations communities for that to be successful. And there are many different sustainable technologies that are available, and some of our recent work, or starting to work, is on 3D printed concrete at Queen's. But I think what we really have to find, and this will come with working with the communities, is what is the right fit and what do communities want? And that will only come through meaningful engagement and dialogue. So just quickly, some acknowledgements of all of those who contributed to this presentation. And thank you for your time. And I'd be happy to answer any questions now, or I know we also have the discussion time at the end, and I should be able to join at that time. So